So this is basically this is an overlay of the system that ThinkRF has come up with. So you've got 3GPP infrastructure out there. You've got this device called the SXM node. Sorry, I should have provided an introduction. The name of our system is Spectrum Experience Management, or SXM, for real-time and continuous spectrum intelligence. So at its heart is this SXM node out there in the field, continuously characterizing and monitoring the RF environment. Information goes up to the SXM cloud. The information from that node and all the other nodes that are out there in the field, might be tens, hundreds, or thousands. All that information is getting continuously upgraded into, or uploaded into the cloud. That data then needs to get presented in an intelligible fashion, either through a dashboard that allows you to probe the information in there and probably further abstract the user from the direct data, the detailed data that's been collected. The users don't want to know specifically, what was the RSRP for that particular PCI at that point in time, although they may. What they want is a faster approach to solving their fundamental issue. All right, so a dashboard might do that, or you want to access that data through an API, which allows you to integrate that data you've collected with other data sources. Excuse me. So a deeper view into SXM. So you might have a network of nodes, and in this case, we actually have a network of these SXM nodes across Canada right now, operating and pulling in data. We've got nodes around the world, but this is in particular a network that we got in Canada, showing kind of a view of the sort of data that's being collected. I'm going to dive into some of this in a little more detail. So 4 fundamental things that we tried to accomplish with this system, getting back to those challenges of RF drive tests today, or traditional approaches. So the first is that easy to use, dead easy. No special training is required. They self-configure themselves in the field. You plug it in, it turns on, it understands where it is, it self-configures itself, and it can reconfigure itself if need be, depending upon what it sees, right? Auto scans the environment, auto connects up to the cloud. There is literally nothing for an installer to do except mount it and provide power, and it will start operating. This is also proven really important as we're installing tens, and well, we've probably got several hundred out there. As these are being installed, you want them to be easy to install, right? Second key thing, we're talking about the challenge that's specific in time. These operate continuously. They're continuously scanning all the FR1 bands. They auto-detect changes in the environment, characterize everything that's going on, and doing comparative analysis, right? So whatever is happening as a new base station shows up, bang, it's seen. As the channel changes its configurations, bang, it's seen, it's reported, right? So we're seeing stuff happening in real time. It's insight driven. So we want to make sure we're not just collecting data, right? We want to take that data and abstract it a little bit further to derive conclusions and insights. Part of that comes through things like integration with third-party data sources. Part of that comes through additional processing that happens in the cloud. For example, event identification, where the cloud sees that, oh, a new base station has shown up. We need to notify the users directly that, hey, this has changed. You need to pay attention. Another key aspect that we built in is continuous upgrades. So these nodes are out there in the field. Technology evolves, new functionality gets added, the nodes get continuously updated. with new data. There's a question that came in about how big is the SXM node. It is roughly about 1.5 foot by a foot by a few inches deep. And we've got another version of the node coming out that's about 1/3 of that size. So fairly small, fairly light, very easy to install. Here's a bunch more features associated with this. I won't go through this in all kinds of detail. Suffice to say that there's a lot of information that these nodes intelligently pull out of the RF domain, and continuous, and we're always adding new items to this. So for example, just last week, all of the nodes around the world were updated to characterize whether a 5G channel is standalone or is it non-standalone. All the nodes out there are, now doing that. All the nodes last week were also updated to start scanning for 3G networks. So as the over time, these nodes actually get better and better. Installation and setup, dead easy, right? So step one, attach it to a pole or in a vehicle with an external data mount, connect the power to it. Node takes care of everything else from that point to self-configure itself and connect to the cloud, and then you access the data. And that's it. Very easy.